Okay, this is chapter 9, section 4, the tangent ratio. A trigonometric ratio is a ratio of the lengths of two sides in a right triangle. It's used to find the measure of a side or an acute angle in a right triangle. So, for example, we know that if we have a right triangle, we've got an A, a B, and a C. Any combination of the ratios of A, B, and C, A over B, A over C, B over C, etc., will be what we call a trigonometric ratio. So let triangle ABC be a right triangle with an acute angle at angle A. The tangent of angle A, written as tan A, is defined as follows. The tangent of A is the length of the leg opposite angle A over the length of the leg adjacent to angle A, which is, in our case, BC over AC. The tangent of A is little a over little b. So let's find angle A. The tangent says that the side opposite angle A, which is little a, is your numerator. That is what goes on the top of the fraction. And then the side adjacent to the angle, that is not the hypotenuse, the leg adjacent, which is B, is your denominator. Okay? Express the following as a ratio. So we've got tangent of R as a ratio. Let's find angle R, which is right here. Let's go across from R. That side is 3. So 3 is our numerator. And then our denominator is going to be the side adjacent to that angle, but not the hypotenuse. So the reason we're picking RT, which is 8, and not RS, this one up here, is because RS is our hypotenuse, okay? You must use both of the legs for the tangent ratio, okay? I'll write this also in terms of its sides. This is ST over TR, okay? Remember, you should use both legs for the tangent ratio. Okay, let's do the tangent of S. The tangent of S, let me erase what we did for R. So we're going to locate angle S, which is right here. And the numerator is going to be the opposite, which is the side 8, over the adjacent leg to this angle. The adjacent leg is 3, so that's going to be 3 in the denominator. Or this is TR over ST. Okay? We're going to do 2 more examples like this, okay? Let's say we have another right triangle, A, B, and C. And we're given that this side is 7 and this side is 3. Tangent of A is what? Seven over 3. Why? Christina, why? So the 7 goes on the top. Good. It's the adjacent side. So the 3 goes on the bottom because it's adjacent. Adjacent means next to, right? That 3 is next to the angle that we're looking at. So then the tangent of B equals 3 over 7. Okay? One more example, and then you guys will prove to me that we are good to go. Draw another right triangle. Make this your 90. This is A, B, and C. 5 and 4. I want to know the tangent of A. What do you guys think? What's that? 4 over x. Very good. But let's say could we solve for x?
That face means yes.
With my face, that means yes. It does mean yes. But how do we solve for x, people? We kind of did like all of these on our quiz. Yes, x squared plus 4 squared equals 5 squared. I'm going to set it up a different way though, and tell me why I'm wrong. X squared equals 5 squared plus 4 squared. Why is this incorrect? Luciana?
I might be wrong, but because the hypotenuse is 5.
Very good. The hypotenuse is 5. So that's our C, right? C has to be on the one side of the equation by itself. A and B add up to C. So let's rearrange this. Let's erase it. This should be x squared plus what? 4 squared equals 5 squared. So let's just solve for x. This is going to be x squared plus 4 squared is? Really, guys? Not 24. 16. And 5 squared? 25. How do we solve for x? Subtract what? 16. We're going to get x squared equals 9. So what's x? 3. Now we can find the tangent of A. What should the tangent of A be? If this is 3. 4 over 3. And the tangent of B? 3 over 4. This is the calculator portion. We will go over this slide in class. It's too complicated for me to go over in a video. So just put in class on your slide and we will go over it together. I need you guys to have is a scientific calculator. You don't need it right now, okay? But I'm gonna show you what you're gonna be able to do with it. In the meantime, okay, you can always just Google scientific calculator. I found a nice website. I'll show it to you guys right now. It's got this really neat calculator on it, okay? Calculator.net, scientific calculator, okay? Super easy. You can just Google it. There's a bunch of sites like this, okay? Just when you're doing your homework, make sure there should be an option for radians or degrees. Make sure you're always in degrees, okay? You guys probably don't even know what radians are, so then you should always be in degrees, okay? So can you guys see what I'm talking about? Yes, you can. Okay, so let's go back to our notes. The tangent of 45 degrees, okay? On your scientific calculator, there is a button called the tangent button, okay? And it has a parentheses. All you're gonna do is click that tangent button, and inside those parentheses, you're gonna put 45, and then you're gonna get output an answer, okay? Let's see what we get. Let's click our tangent button. Whoops, let me clear it. Click our tangent button, and then we're gonna click 45 and press enter. If you are in degrees, you will get the answer 1. If you're in radians and you click enter, tangent of 45, you'll get like 1.619. That's not correct. You wanna be in degrees and you wanna click tangent of 45 and you should get 1. Okay, so back in our notes, we're just going to put a 1. Now, why is it 1? Let's check it out. Let's say we have a triangle, a right triangle, and this angle is 45 degrees. What kind of triangle is this? 45, 45, 90. So if this is A, what is this bottom side? A. What's the hypotenuse? A square root of 2. A times the square root of 2. Now remember, tangent is opposite over adjacent, right? In terms of the legs. So the tangent of this 45 degrees is going to be what? Christian? A over A. What is A divided by A? 1, right? Was that our answer? Absolutely. Okay? Absolutely. Now, the tangent of 36 degrees. Is there a 36, 54, 90 special triangle? No, so this one's going to be a weird number, okay? But all we have to do is we're going to switch over to our calculator, and we're going to put the tangent button, and we're going to click 36 and press equals. I want you rounding to the hundredths, okay? So our answer is 0.73. That's the only way you can find the tangent of 36 degrees, is to plug it into a calculator. So let's switch back. This is going to be 0.7, what did I say, 3? 0.73, okay? Now, there are going to be some instances where you're going to know the ratio, but you're not going to know the angle, okay? This is an example where we use the tan inverse, okay? So in your calculators, you're going to find a button that says tangent with a -1 exponent, or it's going to say arc tan, A-R-C tan. Either one, they do the same thing. So tan inverse or arc, A-R-C tan. And then it's going to have parentheses afterwards. And you're just going to plug in the number that you're given. So in this case, it's 2.4751 or 2.4751. Make sure you're in degrees, and let's check it out. So we're doing the tan inverse or arctan. So it should be this button with the -1. Do you guys see that? And then we're plugging in 2.4751. And we press equals. So the tan inverse of that value is 68 degrees. Okay, before I do it, what would be the inverse tangent of 1? Think about it. What would be the inverse tangent of 1? Christian? 45. Let's see it. Inverse tangent of 1. 45. Why? Because the tangent of 45 degrees is 1. Do you guys get that? It's just doing the opposite operation. So it's saying, okay, we know what the value of the tangent is. Let's do the inverse tangent and find the value of the ratio. Okay. Let's go back. We're going to fill this in. This was 68 degrees. So we're finding the tangent of a value, which is a degrees, okay? So we're just going to use the tangent inverse of this value, which is Okay, so using the tangent to complete a triangle. Example 3. All right, so find the tangent of A and the tangent of B. So A is right here, angle A. We're going to go across from A. That side is 2, so that's our numerator. The adjacent leg to angle A is 7. That's the side that is part of your angle, but not the hypotenuse. Notice how we didn't pick BA. The reason we didn't pick BA is because that is our hypotenuse. So this is 2 over 7. The tangent of B would be this one. This is angle B. Opposite is 7. And then adjacent is the 2. So this would be 7 over 2. Now, the measure of angle A, the measure of angle B, that will come when we have our calculators in order to calculate this. But for now, those are the only two that I want you guys to do. Okay, so take a look at this example, which you guys should have already done in the notes. So we found the tangent of A and the tangent of B, okay? If we want to find the actual measure of angle A, all we're going to do is we're going to take the tangent inverse of 2 over 7, and that will give us A. In this case, we're going to take the tangent inverse of 7 over 2, and that should equal B. So we're going to switch back over to our calculator, and we're going to take the tangent inverse of 2 divided by 7, which is 15.94. We're going to round that to 16 degrees. Make sure you're rounding your degrees to the nearest degree. So this A is 16 degrees, and B is going to be the tangent inverse of 7 over 2. So let's take the tangent inverse of 7 divided by 2. 74.054. 74 degrees. So 16 degrees and 74 degrees. Someone tell me why angle A and angle B add up to 90 degrees. Someone tell me why 16 plus 74 equals 90. Because what? C is already 90. Very good. So A and B must be complementary to add up to 90 degrees, right? Because it's a right triangle, so those two angles will always add up to 90. Okay? That's a great way to check yourself for these kinds of problems. Okay. I know many of us, actually probably all of us, have not seen tangent before. Okay? It's just a trigonometric operation. Okay? It's on your calculator. It just means the opposite leg over the adjacent leg. Never use the hypotenuse when you're talking about tangent. Okay? All right. Let's move. Okay, complete the triangle. This would also involve a calculator, so you're going to skip this one. To example 4. We skipped it in the notes on the video, but we're going to do it now. We need to complete the triangle. That means we need to find out every single angle and find out every single side. We know that 2 of the sides are 8 and 17, and our last side is unknown, and we only know that one of the angles is 90 degrees. Where do I start? Find the tangents? Okay, so what's the tangent of A? 8 over x. Good. So we can't do anything until we find x, right? Can we find x? How do we find x? A squared plus b squared equals c squared. So someone set it up for me. Oh no, what happened? Did it come back? Okay. Go back. Okay, someone set it up for me. A squared plus b squared equals c squared. X squared. Good. Why is 17 the one by itself? It's the hypotenuse, okay? Your hypotenuse, which is the one opposite the 90, always goes by itself on the one side. It's your C. So you square it and you leave it by itself. Okay, so this is going to be x squared plus 64 plus, or equals, what's 17 squared? 289. How do I solve this? What am I going to get? X squared equals 225. What do I do next? Square root of both sides, and we get x equals? Good. X equals 15. So we know that this is 15. So what's our tangent ratio now of A? It's not 8 over x, it's 8 over 15. What's the tangent of B? (15/8). So A is going to be equal to the tangent inverse of what? 8/15. And B is going to be the tangent inverse of 15/8. And A plus B should give me what? 90, okay? Let's check it out. So we want to find the tangent inverse of 8 divided by 15. We get 28.07. Round to the nearest degrees, that's going to be 28 degrees. Okay? So A is 28 degrees. What about B? So we want the tangent inverse of 15 divided by 8. 61.92, in other words, 62 degrees. Let's go back to our notes. Do 28 and 62 add up to give you 90? Yes, so we did it correctly. So this angle down here is 28, and this one is 62 degrees. Is that the bell? That is? Okay, perfect timing. All right, guys.
Okay, and then this is the last example that we're going to do, example 6, okay? So, use a special right triangle to find the tangent of a 60-degree angle. So, let's just set up a picture in terms of what we know. So, we have a right triangle, 90 degrees. One angle is 60 degrees. And the other angle is 30 degrees. So we know this is a special right triangle because it's a 30, 60, 90, okay? Again, we're just gonna label, we're gonna use any variable. I'm gonna use A, you could have used X, you could have used Y, you could have used whatever you wanted. But remember, the side opposite your 30 is your smallest. So we're gonna put that one as A. The side opposite this 60 degrees, your other leg, is gonna be the square root of 3
times A, and then your hypotenuse is 2 times whatever the value of A was, okay? So the tangent of the 60 degrees, that would be this one, would be square root of 3 times A, because that one's opposite. So the tangent of 60 degrees is the square root of 3 times A divided by the side adjacent to that angle. That is the leg. That would be A. So when we look at this, things are going to cancel. These A's will cancel. So we get that the tangent of 60 degrees is the square root of 3. That's it. Okay, so a lot of these slides I'm not going to get to because they require me to be in class. But for now, this is what we're going to use. We will go over the rest of the examples on Friday in class. Look for a modification on your homework in terms of which questions to do.